In this video, we are going to learn proposition 2 from the second unit of measure and integration. Okay, so here is the statement. In this statement, first thing to be noted is it is an if and only if statement. So we all know how to prove the if and only if statement, right? Yes. So let's read this statement. Here they are given you a function f and they are saying this function is on the measurable set E. Okay. So if you want to say this f is measurable, if and only if f inverse of script O, this is script O. Okay. Don't think it is theta, it is script O. If and only if f inverse of script O is measurable and okay. So you are proving like this. First what you are doing is you are going to assume f inverse of script O is measurable. The script O is an open set, okay, that is given in the question also, in the statement itself. So here nothing is there to understand. Only thing is you are going to say f is measurable if and only if f inverse of script O is measurable. Script O is an open set in E. Am I right? Yeah. Okay, so here you are assuming this. First you are assuming f inverse of script O is measurable and you will prove f is measurable, and then in the converse part you will assume f is measurable and you will prove f inverse of script O is what? Measurable. So here I told you the script O is an open set in R, okay? O is an open set in R. I mistakenly told you it's an open set in E. I'm so sorry, it is an open set in R. In between they have wrote like that. Okay, let's see the proof. So assume f inverse of script O is measurable. To prove f is measurable, you know that to say f is measurable, you can write if f is, you can write like this, right? From the first proposition you can write like this. If you proved this is measurable, then you can directly say f is measurable. So you are considering this x belongs to E such that f of x greater than C equal to f inverse of C comma infinity. That is how you are considering. This equal to this you are considering. We know that C comma, you have to write like this. C comma infinitive is an open set. So open set is always measurable. So C comma infinitive is measurable. If this is measurable, then f inverse of C comma infinity is also measurable. If this is measurable, then the left hand side will also measurable. If this is measurable, then you can say f is measurable. So that is how you are proving the first part of this proposition. You can have a look at this, how they have wrote it, because I did not write all the sentences. So if I don't show this, then you will get confused about how to write the steps in the proof. Okay, so that is how I'm showing you the first part here. You can have a look at this. Now let us pass on to the converse part. In the converse part, you are assuming f is measurable and it will prove f inverse of script O is measurable. Okay. Now what you are doing is we have to prove f inverse of script O is measurable, right? So before that what you are doing is you are giving some value to the script O, that is let script O is equal to union k is equal to 1 to infinitive ik. So you know that this ik is a countable collection where you have to write like this. What about this ik and all? You have to write that, right? You are writing where ik is the countable collection of open intervals and ik is equal to bk intersection ak, where bk and ak are measurable. Okay, if bk and ak are measurable, even when you take the inverse, that will also measurable. Therefore f inverse of bk and f inverse of ak also measurable. Therefore you can write, you are taking f inverse on both sides to this. You are taking f inverse so that you will get this. So in the place of union k ik, you are substituting the value that you have here. Okay. You're substituting this value in the place of ik. Now what you are doing is you are bringing this union to outside so that you will get this step, and you can say this is measurable. That the reason is because in few steps before you have wrote that this F inverse of BK and F inverse of AK is measurable, right? So from this you can say even when you take the union of these two, you are going to get the measurable set. So that is why can you understand, even if you are finding F inverse of these two also will be measurable. Therefore from this you can say this is measurable. If left hand side is measurable, this will also measurable. Hence the proof. This is what we have to prove, right? F inverse of script 2 is measurable. You can see my note there. You can see each and every steps of the proof. So have a look at this. I gave you a short note on the proof and I told you what is there in the proof. So here you can see the clear cut steps that you have in this proof. Thank you.